Let's see. No. Gotta change this. Gotta change this one right here. Alright, now we're ready to go. Let's just quick review from what we did yesterday. If you had a line that's like this, how would you describe this line for right now? How would you describe this line? What kind of line or what kind of slope is this line? It's going up, but it's positive slope, right? This is a positive slope, okay? Because from left to right, it's going up. All right. What about that line right there? What would that be? That'd be a negative slope because again, if you go from left to right, you would be going down the hill, wouldn't you? So that's a negative slope. Let's see if you remember this. What if you had a slope that was horizontal like this? What is it? It's zero, right? It's zero slope. All right. It does exist. There is a slope. All right. It does exist, but it's a zero slope. Zero is a number, isn't it? Right? We use zero all the time for things. We can add a zero, subtract a zero, multiply by zero. All right, we can do things with zero. So zero is a number. It does exist. So there is a slope like this. Remember, if you go to a ski resort, you could ski on something like this, couldn't you? All right? It'd be no problem, okay? So that does exist. Yeah, this would probably be even less than the bunny hill. This is probably just to get to the bunny hill when it's just flat. The bunny hill would be like this, and then you get up to the diamonds and it would look like this. Yeah, that's what they call it. Not officially. I don't think there's a sign that says this is the bunny hill, but that's what people call it. Now, this is one thing that you will not see at a ski resort, all right? Is a slope that looks like this. We talked about that. So what is the slope, girls? Undefined. This is undefined, right? It's undefined. Remember, because if I went down this thing, I'd fall, hit the bottom, and you wouldn't be able to define me. You wouldn't be able to tell who I am. All right, so it's undefined. It does not exist. You could say a couple things. You could say there's no slope. What's that? DOA? All right. We say this is no slope. We could say it doesn't exist. We could say it's undefined. All right. Most of the time, we would either choose one or two of either undefined or no slope. Right? But there is a difference between no slope and zero slope. Agreed? Yeah. Okay. So that was all review. What we're going to do today is we're actually going to find the measures of the slope. We're going to actually find what the slope is. Before we go to the next part, let's just review very, very quickly here. Let's say we had a line again, and oh yeah, we talked about this. Okay, so let's say you had a point right here. We'll just put them on the ends this time, and you want to find the slope. Okay, we're going to do this with actual numbers today. All right, but yesterday we said we would do what? We would count this way, and then we would count this way, like that. This was the rise, and this was the run. Okay, so the slope is, slope equals rise over run, and that's very important. Okay, that's something that you need to know. We're gonna take that to the next level today. All right, it's rise over run. Here's another thing I didn't tell you yesterday. They have a letter that represents the slope. Georgie, get your head up, please. They have a letter that represents the slope. Do you remember what letter that is from algebra? It's M. It's a letter M. It's kind of weird, isn't it? Have a M to represent the slope. Why in the world M? Well, I asked the same question, I don't know, a couple years ago, I guess, and somebody was asking me, why do they call it an M? I guess I'd thought about it, but so I figured, what do I do? In today's technology, what do? You Google it, right? Okay, so I Googled, what does M stand for in slope? And to tell you the truth, they're not really sure exactly. There's not 100% agreement on this, but I think most people kind of tend to believe that it came from a Latin word. Forget what the Latin word is off the top of my head. I don't know any Latin at all, okay, but it comes from a Latin word that kind of describes mountains and talks about mountains, and that starts with an M, okay? The M doesn't actually stand for mountain, but it has something to do with that. And if you think of mountains, it kind of makes sense, doesn't it? Because it's steep, right? Usually a mountain's kind of steep, and you walk up a slope to a mountain, or you come down the slope of a mountain. So you could think of that M as meaning mountain, right? It doesn't mean exactly mountain, but you could think of it that way. Josh, right here today. Okay, right here. Thanks. All right, enough of that. Let's actually do some real slopes. And I have another window. Look at that right there. So what we're going to do is we're actually going to put some stuff in here. And we're going to draw a line and all that kind of stuff. Let's put a couple points in here. Let's pick a point like right here. Just picking just any old point. And let's pick one about right here. Okay, that's good. And then I'm going to connect the two dots. If I connect the two dots, then I made a line. Would you agree? So if I give you 2 points, or if they give you 2 points, then you connect the 2 points and you've got a line. So I'll connect this point and this point right here, and I got a nice line. Everybody good so far? So what I want to do is I want to find the actual slope of this line. I'll remember what the slope is. I'll use M from now on instead of writing the word slope. Remember what the slope is? It's the what? It's the rise over the run. But what we're going to do is we're going to come up with a little bit of a more specific type of formula for this. But we're going to figure out how to do that. And I'm going to use a different color for this next part. Watch what I'm going to do. I want to find the rise. So I want to go from here, where? Down to right there. Would you agree? And then I'm going to go across. Right? I wouldn't go down below it because this wouldn't be straight across, would it? I go down until I'm even with the next point. Everybody see that? So I got to count down until I'm even with the next point. Let's actually draw a line there just so we can kind of see it. So I'm going to draw the line about right there. All right? And then I'm going to do what? Go from that place to the actual point, and I'm going to run over. Everybody see that? So those 2 purple lines right there represent my rise and my run. So this is the rise, and this is the run. Now you could rise and run the other way too, couldn't you? If you wanted to, you could start from this bottom point and you could rise, which means you go up to this point right here, and then you would run across. You're going to get the same exact slope no matter which way you go. You could go from the top point to the bottom one, or you could go from the bottom point to the top one. It really doesn't make any difference. I don't know, for some reason it seems like I always go from the top one to the bottom one, but it doesn't matter. All right? So let's actually count. Okay, each of these blocks is a 1, so let's just start right here. Let's figure out how high this is. What is the rise? Well, let's just count. 1, 2, 3, 4, 5, 6. So we went 6. But which direction did we go? It's really important that you put the direction. We went down, and down is negative. So we went -6. Now we're right here. Now we got to go over to the point. So let's count over. 1, 2, 3, 4, 5, 6. How about that? It's the same thing. I didn't mean for it to do that, but it just happened to be. All right, so I went over 6. But which direction did I go? I was here, and I went to here, didn't I? Did you see that? So this went down, and this went to the left, so it's what? It's -6 as well, isn't it? Everybody see that? I wish I wouldn't have made these the same. I should have noticed that when I did this, but that's okay. So what is the rise? The rise is -6, and the run is -6. Do we leave it like that, though? If you left that as a fraction? No, you wouldn't leave it like that. What's negative divided by negative? It's positive. And 6 over 6 is 1. So the slope of this is 1. Tell you what, let's change this up just a little bit. Is that all right? Let's bring this down. Oops, I don't want to do that. What did I want to do? I'm going to do that. Oops, didn't want to do that either. This is what I want to do. That, and then this will move it. Oh, goodness gracious. Let's just draw the whole stupid thing over again. Sorry for my language. Calling it stupid. Wasn't very nice, was it? You're probably thinking the same thing though, right? This is stupid. Alright, let's do another line. Let's put it, I don't know, let's go in the other direction. Alright, let's put about like right here. And let's put one maybe about right, I don't know, let's say about right there. Is that alright? Let's find the slope of the line that's connected by these two, or let's find the slope of the line between these 2 points is what they're going to say. Did you hear what I just said? Find the slope of the line between these 2 points. So that means these 2 points make a line. So I'm going to draw that line. The line could keep going through, right, the 2 points, but I'm just going to stop and start right at these 2 points. So again, let's do the same thing. Let's do some green. Oops. Sorry. I'm going to get color coordinated here. There we go. Alright, now we're good. So watch what I'm going to do. I'm going to do the rise and the run. So I have to rise to here. Now look what I'm doing. I'm going from the top one to the bottom one. Or if I wanted to, I could go from the bottom one, what? To the top. If I just decided to go from the top to the bottom. And then this would run over like this. Alright? So let's figure out what the rise is. Let's just count the rise. What is it? 1, 2, 3. We went down, so it's -3. That's the rise. What about the run? Starts here and it goes what? 1, 2, 3, 4, 5, 6, 7, 8. So I went in the positive direction that time, so what's my run? It's +8. Okay? So now I figure out my slope. My slope is rise over run. So now I can plug those numbers in. The rise was -3, the run was +8, and that's my slope right there, -3/8. Don't take that -3/8 and make it into a decimal. All right? Sometimes your slope will be a little steeper than this, and it'll come out to an improper fraction. Just keep it an improper fraction. All right? Don't change it into a mixed number. All right? Your slope should always be written as just a one single fraction. Everybody hear me? Do not put it into a calculator and get a decimal answer. I won't accept it. I'm telling you right now. If you put this in a calculator, or let's say it was an easier one. Let's say it was -4/8. What's -4/8? Reduce it. What's 4/8? Come on, reduce it. 2 over what? 2 over 4, right? And what's 2 over 4? 1/2. 4/8 is a half, right? Everybody okay with that? You're scaring me a little bit. 4/8 is a half. Okay, so it'd be -1/2. Don't write it as -0.5. Do you hear me? So don't take a half and make it 0.5. Don't take 3/8, put it in the calculator, and get some decimal for it. Okay, I will not accept it. I want to see the rise, and I want to see the run. Everybody got that? That's very important. I want to see both of those things right there. All right, so that's how you find that. Now, what if we did this? What if we didn't want to graph it, or what if they didn't give the graph? What if they didn't want to put a graph here and they just gave you the points? What is this point right here? Let's count over. 1, 2, 3, 4, 5, 6. -6 and what? +2, right? So that's that point right there. What's this point? 2, -1. What if they did this? What if they just gave you the 2 points and they didn't give you the graph? Would you have to graph it to be able to find the slope of this? No, you wouldn't. And I want to show you how we do that, right? Without actually having to graph it. I graphed it first just so you could visually see what we're trying to do. But what they're going to do is they're going to give you 2 points. They're going to say, find the slope of the line between those 2 points. It's very, very simple, actually. Because look, how in the world did you get -3 right here? Now, this was the rise, wasn't it? This was, which axis are we going up and down on right here? This is the y-axis, right? It's vertical, so it's the y-axis. So look at the y points. Look at the y points. 2 and -1. You could get 3 or -3 by doing what to those points? Would you add the 2 together? 2 plus -1, is that 3 or -3? No. So what do you think you're going to do to those 2 points? You're going to subtract them. So let's try it. Let's try subtracting the y points from each other. This one and this one. What do we get? 2 minus what? -1. What's 2 minus -1? It's +3. And you're like, wait a minute, I thought that's -3. But watch, it works out either way. What about the run? So I went 2 minus -1. What do you think I'm going to do with the x's? That's right, -6 minus what? 2. So let's do -6 minus 2. -6 minus 2, add a line, change sign. It's -8. So what is the rise over the run here? It's 3 over -8. Is that the same slope? Is that right there? Yeah, it is. It's exactly the same slope. Doesn't matter if the negative's on the top or the bottom. It's the same exact slope. Everybody see that? So really, what did we do? We just took the y's and did what to them? What did we do to the y's? We subtracted them. What did we do to the x's? We subtracted them. Which one did we put on top? The y's, because it's rise over run. So we put the y's over the top. So let me show you a nice little formula, and this is a formula that you need to know, you need to memorize to be able to find the slope of a line between these 2 points. So it's not y equals mx plus b. All right, we're just finding the slope. Okay, we're just finding the slope. So what do we do? It's rise over run. How did we find this distance? How did we find this length? We subtracted the y's from each other, didn't we? All right, so watch. I'm going to subtract the y's from each other. You've seen stuff that looks like that before. Okay? And it doesn't matter if it's 1 minus 2 or 2 minus 1. It doesn't make any difference. As long, listen to what I'm saying. It doesn't matter which order you subtract the y's in, as long as you subtract the x's in the same order. Okay, you got to subtract the y's and the x's in the same order. So if I go the first one minus the second one for the y's, I got to go the first one minus the second one for the x's. I could have done it the other way, couldn't I? I could have gone -1 what? Minus 2, right? And then I could have gone 2 minus -6. Do we get the same thing? Do we still get -3/8? Yep, that's -3. That's +8. We sure do. So it doesn't matter what order we subtract them, as long as you subtract them both in the same order. You got it? All right, so what's this going to be? y1 minus y2 over, what do you think? x1 minus x2. You see why we put those numbers in there? These are the y's. What did I do? I subtracted the y's. This -6 and 2 are my x's. How did I get that -8 out of that? I subtracted the x's. Remember, the y goes on top and the x goes on the bottom. How can you remember that the y goes on top? Because this is the same as what? Rise over run. You see that? The y is always the rise. Think of the y-axis. Y-axis goes up and down, doesn't it? That's the rise. What about the run? What axis is the run? The x-axis, okay? So it's y over x. Even in my, I've been picking on my honors class a little bit because the other class period, I talked about them. But even in, because we have already taken a test on this in the honors class, even in that class, people are mixing it up. They're putting the x on the top and the y on the bottom. And I kind of understand why they would do that, because you're thinking, oh, x goes first, y goes second, so x goes on top. But that's not how it works with slope. It's rise over run, the y over the x. Everybody see that? So make sure that you understand that. So put that in a box somewhere. Put it away. Save it. Put nice colors on it. Put bells and whistles on it so you remember what it is, okay? So that's it. That's the formula for slope. So here's what they're going to do. In fact, let's go to the other background, because with all those graph lines on there, it's kind of hard to write on there. So let's go back to this. All right. They're going to give you like a couple points. I'm just looking in the book for a couple. So they give you 3, 6, and -9, 2. And the question will say, find the, what do you think they're asking here? The slope. Find the slope between, find the slope of the line between these 2 points is basically what it's going to say. All right, find the slope of the line between these 2 points. Well, we need a formula, don't we? Well, we just figured out our formula. What is the formula of the slope? It's the, right, y1 minus y2, so you subtract the y's, and then you put it over what? Subtract the x's, right? So if you can just remember that, you don't even have to memorize y1 minus y2. You can just think of subtract the y's, put it on top, subtract the x's, put it on the bottom. You see that? It's pretty easy. So let's put some numbers in here. Let's subtract the y's. So let's just not do it in our head. Let's write it down. So the y's are 6 and 2. So if I go the first one minus the second one, I got to go the same order with the x's. So what's the order of the x's? 3 minus what? -9. Good. A lot of people, you know, a lot of people do on this. They'll put 3 minus what? Yeah, a lot of people just see the 3 and the -9, and they put 3 minus 9. But it's not, is it? It's 3 minus a -9. That's supposed to be a 9 right there. Looks kind of ugly. Making it worse. So 6 minus 2 is 4. And then 3 plus 9, right? Add a line, change sign. So what's that? 12, right? And then we reduce it. Don't leave it like that. Always, always reduce it. Right. 4 goes into that once. 4 goes into that 3 times. And it's 1/3. So that is your slope right there between those 2 points. What does that mean? That means for every 1 you go up, you go across 3, right? That's how steep the line is. If you just go up 1, you got to go over 3. And that's the slope of the line. Not a very steep line, is it? What do you think is steeper? Do you think 3 over 1 is steeper or 1 over 3? 3 over 1, right. Because what do you do on 3 over 1? You got to go up 3 and then just over how much? Just 1. That's a pretty steep line, isn't it? But if you just go up 1 and over 3, flattens out a little bit more, doesn't it? Does that make sense? So I want you to picture in your mind what the slope is. Don't just don't just throw numbers into a formula and get an answer out of no idea what you're doing. What you're doing is you're finding out how steep that line is. That's what you're finding when you find this. Okay? Let me talk about something else here. Then we'll do another example, then we'll quit. Let's do this in yellow. Watch this. Here's a line. I'm going to copy it and paste it. It's right there. So the lines are exactly the same. Same length, same slant, everything. All right? Just one's a little higher than the other one. So what do you think is true about these two lines then if I copied and pasted? They're parallel. Okay? They are parallel to each other. All right? Put the arrows on there. Now they definitely are parallel, aren't they? Now, what do you think is true maybe about the slope of this line and the slope of this line? Yeah, they're equal slopes. They're exactly the same. Now, we don't say congruent, okay? We don't say the slopes are congruent. We say the slopes are equal, okay? Because we're talking about a measurement. We're talking about a number. So the slopes are equal to each other. They have the same slope. So, for instance, if you went like up to and over 5, let's say. So let's say the slope of this was 2/5. That looks reasonable, doesn't it? So if the slope of this line is 2/5, what's the slope of a line that's parallel to it going to be? It's going to be 2/5, exactly right. So that's really easy. So they're going to have some problems. They're going to have some things. They're going to say, you know, here's line A, you know, and the slope of line A, they wouldn't put a capital, but let's say the slope of line A is, I don't know, negative 1/3, okay? And then the slope of line B is also negative 1/3. Tell me something. It's all you know about these. You don't know what the graph looks like. You don't know anything except for that. What can you say then about the two lines? If this has a slope of negative 1/3 and this has a slope of negative 1/3, what's true about these two lines? They are what? They're parallel. Okay? And they're going to ask you some questions like this. All right? You're going to have to sometimes figure them out. They might not tell you exactly what the slope is. Sometimes you're going to have to figure out what the slope is. And we're going to do an example here in a few minutes that does that. All right? Stay awake. Come on. It's not that bad, is it? Georgie, second time. 3 strikes and you'll be out. Okay? So look at this. These are parallel because they have the same slope. Check out these lines, though. These lines are not going to be parallel. Any wild guesses on what kind of line you think I'm going to draw? Okay, they're going to be non-parallel, but they're going to be a little more specific besides just non-parallel. What'd you say? Yeah, they're going to intersect, but they intersect each other, but that really doesn't tell me much. If I had parallel, what's another P word that we describe lines? What? Come on, we've used this word before. What is it? Perpendicular, right. Perpendicular lines. All right, so look at these two. And we'll put the little box right there just to show that they're perpendicular. Now let me ask you this. Are these two slopes exactly the same? No. I'll tell you, let's label them so we can talk about each line. So this one down here is L, and this one right here is M. All right, look at line L. First of all, is it a positive or a negative slope? Positive. It's positive because it's going up. What about M? What is that? Negative. That's negative. So watch. When two lines are parallel or perpendicular, let me say that again. When two lines are perpendicular to each other, if one slope is positive, the other one is going to be what? It's going to be negative. That's always true. But there's more to it than just that. There's two things that are true about it. Both lines, one line is positive and the other one is negative. But look at how steep it is. Pretend, remember I went skiing and I drew a picture. Didn't I draw a picture of me skiing? There's me skiing. Looks like I'm sitting on my butt or something, doesn't it? All right, but anyway, I'm sliding down this hill. Doesn't it look fun? All right, so I'm sliding down this hill right here. Tell me, what kind of hill is this compared to if I went on this hill? Whee, my arms are out. Okay, so I'm going down this way, and I'm going down this way. Well, I labeled the lines, so tell me about the lines. That's right. L is a lot less steep than M is. Would you agree? This is kind of like the bunny slope, and this is like the black diamond, the double black diamond. Okay, it goes really steep. So do they even have the same slope? No, they don't. In fact, one slope is actually the inverse of the other slope. For instance, if this slope right here, the slope of line L was, I don't know, it's positive, right? What do you think? Rise, run, So it's, you know, little rise compared to a longer run. So let's go, I don't know, 2/5. Is that all right? And it's positive, agreed? This slope right here, if it's perpendicular, this slope right here of this line, first of all, is it positive or negative? It's negative. And what did I say about the number of the slope? It's a what? It's an inverse. That's right. It's an inverse or a reciprocal. You know that word, don't you? Reciprocal means you do what to the fraction? You flip it. So it's going to be negative what? 5/2. Exactly right. And that's going to be true about any lines that are perpendicular to each other. I use this phrase. I say the slopes are negative reciprocals. Every time they're perpendicular. Exactly right. Every time two lines are perpendicular to each other, their slopes are negative reciprocals of each other. Okay? A negative reciprocal. Negative means it's the opposite sign. Reciprocal means you just flip the fraction. So there's two things that you need to do. Remember up here when I said if the slope of line A was negative 1/3 and the slope of line B was negative 1/3, what's true about them? They're parallel, right? So what if I had, let's just make this up. What if I had a slope of a line that was, I don't know, 2/3 and another slope that was negative 3/2? Then what's true about the two lines that have these two slopes? Then these would be perpendicular, wouldn't they? Does that make sense? Because they're negative reciprocals of each other. Now here's what they're going to do. And we'll end with this example, okay? Writing any of this down? It'll help you stay awake if you write this stuff down. Okay, here's a good one. Nobody budged after I said that. 3, 6. All right, and line or point B is negative 9, 2. Now watch what they're going to do. They're actually going to give you 4 points here. This is kind of stuff you're going to be doing on your homework, so it would be a good idea to pay attention and to write this down. I don't know why it's so hard just to copy down what I write up here. I'm doing all this writing, right? I'm working hard. You should be working hard too, shouldn't you? Yeah, I think so. Here's what they're going to do. They're going to say, look at line AB and look at line CD. These 2 points will make line AB, won't they? And then these 2 points right here will make line CD. Agreed? So the question is, are these two lines, are they parallel? Are they perpendicular? Or are they neither? So how in the world, just by looking at these points, will I have any idea if they're parallel? Do I have to graph it to figure this out? That's right. Find the slopes. That's all you got to do is find the slope of this line right here. Find the slope of this line right here. If the slopes are equal to each other, what are the two lines? Come on. I got 3 choices. It's right here.
Parallel.
They're parallel to each other. If the slopes are equal to each other, if they have the same slope, and the slopes are equal to each other, what kind of line is it? It's parallel. What if the slopes were negative reciprocals of each other? What kind of lines would you have? Perpendicular. What if neither one of those things were true? Then it would be neither. All right, so that's what we have to do. So it's actually pretty easy. All you got to do is find the slopes of these two lines and then compare them. So let's find the slope of line AB. I'll put a little AB down here so you know what slope we're finding. Now, remember how to find the slope, right? We just did it a few minutes ago. So, right, subtract the y's, put it on top, and subtract the x's, put it on the bottom. So let's subtract the y's. This is AB. So what is it? 6 minus 2, right. It's line AB, so it's subtract the y's. It's 6 minus 2. Now let's subtract the x's and put that on the bottom. So what numbers do I have there? 3 what? Minus, 3 minus what? Negative 9. Okay? And what's that going to be? 6 minus 2 is 4. That's a plus. That's a 12. What's my slope? It's 1/3. All right, so the slope of this line is 1/3. Now what do we have to find? The slope of CD, right? So we got to find the slope of CD. So let's do that. So let's subtract the y's. So it's 4 minus 3. Remember, the y's go on top. It's rise over run. So 4 minus 3 over what? 5 minus 2. So that's what? 4 minus 3 is 1. over 5 minus 2 is 3. Now here are my two slopes. Those are my two slopes right there. By knowing the two slopes, what kind of lines are those two lines then? Think. They're parallel. Why are they parallel? Because they're equal to each other. That's right. They're the same. When the slopes are the same, when the slopes are equal to each other, then the lines are parallel. All right, so I would just write parallel. Now you may think, oh, this is easy. I'll just guess. I got three chances. All right? Do you really want 3 chances? No. You want a 100% chance, right? You don't want a 1 in 3 chance. You want 3 out of 3 chance. So make sure you know how to do it. Look at the two slopes and decide what they are if they're parallel. Let's say you did. We're not going to do a whole nother problem, but let's just say the slope of AB. That's supposed to be a B. Wrote too fast. Slope of AB was negative 5/7, right? And then let's say, I'm just making this up, the slope of CD was 7/5. So here's the two slopes. I did my work, put it into my little formula. What's true about these two lines right here? Yeah, they're negative reciprocals, right? So they are what? Perpendicular. All right, so they're perpendicular. What if we add this? Let's do one more. What if we had the slope of AB was, I don't know, 2/3, and the slope of CD was 3/2? What's true about those two lines? They're parallel? They can't be parallel because they have to be what if they're parallel? They've got to be equal, so they're not equal to each other. Are they negative reciprocals? They are reciprocals, but look, this is positive and this is positive, right? So they're not opposite. They're not negative reciprocals. So what would you write for this? You'd write neither. Does that make sense? Okay, and that's the kind of questions they're going to ask you. Not for the whole entire worksheet, but for a part of it, a portion of it, they're going to ask you to do stuff like that. And it really wasn't that hard, was it? Finding the slope? It's actually, it's way easier than the distance formula, right? Because you don't have to square anything, you don't have to square root anything and all that stuff. It's actually a little easier than the midpoint formula, because the midpoint formula, you had to add and then divide, didn't you? On this one, the only thing you had to do is do what? Just subtract. That's right. All you got to do is subtract. So this is actually the easier of those three, I think. All right, so we're going to do a worksheet. The worksheet is 3-3. You can do the whole thing. All right, so that will be due on Monday. And you actually got some time in here to get working on it, so lucky you.